Welcome everyone to the lecture series of quick revision which we are doing at Pocket Concepts. So for the today's topic we have projectile motion. Projectile motion is a 2D motion in which this is projectile motion. It is a 2D motion in which we have obviously two dimensions, which is x and y, and let's say we at the time t is equal to 0, we throw a ball, or you can say object, from an angle theta with the x, the horizontal axis, and then the ball or the object reaches a highest point, which we say like here, and then eventually the object reaches the ground with the velocity v. So why does the ball travels in this direction, like going up and then coming to the down? This is because when we throw the ball, there is a constant deceleration of g, 9.8 meter per second square, which we also known as acceleration due to gravity. So due to this small g, we know that the y component, the vertical component of velocity, is always decreasing due to deceleration in the y direction. So there is a point when the y component of the velocity becomes 0, and at that point we reach the highest point. Since the y velocity becomes 0, obviously the acceleration is still applying, then the y velocity becomes negative, and the moment it becomes negative, the direction of the velocity becomes downward. So this is the complete motion. The ball travels with u, and at ground it reaches with velocity v. So what is the some important things about this motion is the velocity with which we start is the same velocity which we reach at the ground. So u is equal to v minus deceleration in y direction. Minus represents the sign convention we have, that the upward and the rightward direction are taken positive. The upward y value is taken positive, the rightward x is taken positive, the leftward x is taken negative, and the downward y is taken as negative. So since the acceleration due to gravity is in minus y direction, so we put a minus sign here. So minus g acceleration we have in y direction, and in x direction we have no acceleration. So this is the basic overview for projectile motion. Then we have the different kinds of information for both dimensions, x-axis and y-axis. Let's see that. So the x-axis, we have the initial velocity u. We have the velocity u, so it can be divided into two components, ux and uy. So ux is u cos theta, obviously we know from the vector chapter, and in the y direction we have u sin theta. So let's consider first the x-axis. In ux, that is the initial velocity in the x direction, is equal to u cos theta. There is no acceleration in x direction, so ax is 0. And a very important point, ux is equal to vx. What does this mean? It means that the initial velocity in x direction is always equal to velocity is always same. It doesn't change during the whole motion. Why? Because acceleration is in x is 0, so there is no change in the velocity. So it is a very important point. We can solve many questions even in JEE Advanced. There are many questions which can be solved using this property, that ux remain constant at all instant. Like at any instant you check the velocity in x direction, it is always same. Then the fourth point, it is the equation of motion, basically the displacement in x direction. So displacement in x direction is equal to uxt plus half at square. Since acceleration is 0 here, so it is equal to uxt. Then we have in y direction, in y axis, we have first point, uy is equal to u sin theta. Obviously when we component it here, it becomes u sin theta. So uy is equal to u sin theta. Acceleration in y direction is minus g. So using the equation of motion, we can say that Vy is equal to, it is going to be Uy sine theta, which is the, it is going to be U sine theta minus gt. So this is the first equation of motion, and the second equation of motion is Sy is equal to Uyt plus half at square, which is, since acceleration is minus g, so minus half gt square. So this is the x and the y axis explanation. So now we start the three important formulas we have for projectile motion. The first formula is time of flight, which is denoted by TF. Time of flight is basically the time the ball takes from when we throw it and the time it reaches the ground. So the journey from t is equal to 0 to the end, let's say the point it reaches the ground is t is equal to tf, which is time of flight. So the time of flight is equal to 2 times initial y component of initial velocity upon g, and 2uy by g. Then we have the other point, which is the max height. Max height is this height, like at the highest point the height would be the maximum, like this is going to be h max. So this h max is equal to uy square by 2g. And then we have the range. Range is the displacement in x direction, like max height is the displacement in y direction. In the same way, range is the displacement in x direction. You can say this is displacement in x direction, r. So what is r? R is known as range, which is equal to ux into time of flight. So these are three important formula we have in projectile motion. Then we have three main important points which we need to remember as note. So the first note is max range is at theta is equal to 45, which means that if we want the range, the displacement in x direction to be maximum, it is equal to, then we need the theta, the angle at which the ball is projected, to be 45 degree. At 45 degree theta we will have the maximum range. If let's say range at let's say theta 1 angle and the range at theta 2, you can say theta 1, let's say we threw the ball at theta 1 and then we threw a ball at theta 2. For both the range came same, so we draw a mathematical conclusion because of it, which is theta 1 plus theta 2 will always be equal to pi by 2, that is 90 degree. Then the third note is very important. I told you this property. This is this property that let's say we throw the ball at initially with velocity u at theta, and then we throw the ball with velocity v. Then it reaches the you can say that then it reaches the let's say at time somewhere t, it is v at angle alpha. So the x, obviously the velocity will change, but we can draw that. I told you that since there is no acceleration in x direction, so the velocity in x direction will be same. In this time the velocity in x direction is u cos theta, and here it will be equal to v cos alpha. So both u cos theta and v cos alpha are same. This property is very important. Many questions are solved using this one. Then we have the average velocity for complete motion. That is the average velocity for complete motion. We have the formula is equal to range upon time of flight. So these are the important points for the projectile motion. And then we have the last topic for discussion, which is equation of trajectory. So what is a trajectory? Trajectory is a path traced by the particle. So if I say let's say the ball goes from here and then reaches the ground, then the path which is traced by the particle is known as, this is the trajectory of the particle. And what is the equation of trajectory? It is the relation between x and y coordinate without involving time t. That is, if we want to create the relation between x and y coordinates, so if we want to create the relation between x and y axis without involving the time, like in equations of motion, like you can say that we relate the x and the y points without the time coordinate, time variable. If we remove the time variable and establish a relation between x and y coordinate, then it is known as equation of trajectory. So what are the equations of trajectory we need to remember? We have first of all, for the equations we need to describe a coordinate system. So if we say that the point where the motion starts, we say it is at origin, and the ball goes up, and at any instant it is x comma y coordinate, this point. So this will be equal to x, and this point will be equal to this point will be equal to y. So the relation, the two equations of trajectory we have are like this: y is equal to x tan theta minus gx square upon 2u square cos square theta, where obviously we know that x and y are the at the instant the value of the coordinates of the object. Theta is the angle at which the ball is projected, g is the acceleration due to gravity, u cos theta is the ux velocity, the velocity, initial velocity in the x direction. Then we have another formula which is very important for the equation of trajectory, which is y is equal to x tan theta multiplied by 1 minus x by r, where tan theta we obviously know, this is the theta, and x and y are the you can say the parameters, coordinates, and r is the range. R is the complete range of the motion. So these are the two equations of trajectory we need to remember. And there is one important point we have, that at the maximum height, you can say at the maximum height here, the differentiation of y with x, like this trajectory equation, if we differentiate it with variable x, then it will be equal to 0. So these are the most important points in projectile motion, and all the formulas and equations we need to remember. So we are going to introduce a lot of different kinds of topics in physics. We have started with physics, we will continue it in chemistry and maths also. So you can revise these chapters good and fine.